Hi, it's Gemma. Welcome to the third Neonates in a Nutshell teaching session, and today we're going to look at blood gases. So why do we monitor blood gases? We use them as a tool to help guide management for our babies and to gain a better understanding of their clinical condition. We can take arterial, venous or capillary samples, and it's important to recognise the type of sample that you've taken, particularly when you're interpreting the results. So what is acid-base balance and what has it got to do with blood gases? So the whole reason we take blood gases is to look at that acid-base balance within our bodies. Our bodies need to maintain a tight biochemical balance, and that's within a narrow range in order to function properly. So changes to acid-base balance either way will affect the normal function of our body and its cells, and so we need to manage that accordingly. Our body produces hydrogen ions, which is the little H plus in the brackets, which are acidic as a byproduct of the metabolism of proteins, fats and glucose, so things that our bodies do normally day to day. Accumulation, so a build-up or depletion of these hydrogen ions, will alter the pH, and this will affect the acid-base balance in our bodies. Acidosis is caused by an accumulation or a build-up of hydrogen ions and is represented by a pH of less than 7.35. Alkalosis occurs when there is a loss of hydrogen ions or when there is an accumulation of base, and we'll talk a bit more about what base is in a minute. Alkalosis is described when a pH is greater than 7.45. So what is an acid? An acid is a compound that gives up hydrogen ions when it's in a solution. So the concentration of hydrogen ions in a compound determines whether or not that solution is acidic or alkalotic. And what is a base? A base is a substance that accepts hydrogen ions. So if acid is added to a base, the acidity of the solution is reduced, and that means a weaker acid is formed. What is a buffer? Buffers are important consideration in acid-base balance. Buffers help resist changes in pH by taking up or releasing hydrogen ions to maintain the pH within a normal range in our body. So buffering agents are really important, and there are three main ones that our bodies use, and those are bicarbonate, hemoglobin and phosphate. So what do our blood gases measure? When we take a blood gas, there are a number of parameters that we need to consider when interpreting them and looking at that acid-base balance. And the first one is pH. So, as we've talked about already, pH is the concentration, it measures the concentration of hydrogen ions and determines the acidity or alkalinity in the blood. And the normal range is 7.35 to 7.45. PO2, or the partial pressure of oxygen, is a measure of oxygen in the blood, and the normal range in arterial blood is 7 to 12. And it's important to remember that that is arterial blood, because if you've taken a venous sample or a capillary sample, then your PO2 is going to be less. PCO2, or the partial pressure of carbon dioxide, is the measure of carbon dioxide in your blood, and the normal range is 4 to 6. Then you've got bicarbonate, which is the HCO3. This is a buffer, as we've talked about already, and it measures the amount of bicarb in your blood, and it's important to consider this range, particularly if the pH is out of range. So a normal bicarb range is 18 to 25. And then lastly, we have our base excess, and this indicates the amount of buffering agent available to mop up excess hydrogen ions, and the normal range is -4 to +4. So when we understand the normal ranges, then we can interpret blood gas results, and this table is a good guide in how to do that. So gases may demonstrate a respiratory acidosis or a respiratory alkalosis. They might show a metabolic acidosis or a mixed acidosis, or they may show compensation, where your body is acting to overcome shifts in acid-base balance. So we've got some examples for you to work through. You might want to use the table on the slide before to help you, and you might want to pause the video here just while you do that. So let's look at these examples. The first one shows us a respiratory acidosis. So the pH is low at 7.25 and the PCO2 is raised to 9. The second example gives us a metabolic acidosis, which shows a low pH again of 7.24. This time the respiratory parameters are normal, but the bicarb is low at 14 and the base excess is low at -8. The third example is a mixed acidosis with a low pH of 7.22 and a raised PCO2 this time of 8, but the bicarb and the base excess are also low, so that's why it's a mixed acidosis, because you've got both respiratory and metabolic components. The fourth example is a metabolic acidosis with a low pH of 7.19, a low bicarb and a low base excess. And then finally, the last example shows us a compensated gas. So the pH is basically within normal range. The respiratory elements are also normal, but you've got a raised bicarb and a raised base excess. So I hope you found this teaching session useful, and if you have any questions, then drop us an email or come and chat to any of the ANMPs on the unit. Thanks very much.